What if our buildings could actually heal themselves, fix their own cracks? And what if making concrete, the most used material on Earth, could be a green, sustainable process? Sounds like something out of a sci-fi movie, right? Well, it's very real, and it's called biocement. Today, we're going to break down this incredible technology based on some amazing research by Mr. Rushikesh Tahakik.
I mean, just take a second and look around. The house or apartment you're in, the roads you drive on, the massive dams and bridges that shape our world, it's all concrete. It's not an exaggeration to say it's the literal foundation of our entire modern civilization. But for everything it gives us, there's a hidden cost. A pretty heavy one, actually. And it's a bill that's coming due for our planet. So before we can really appreciate the elegance of the solution, we have to get our heads around the massive scale of the problem. And that problem starts with cement, the key ingredient that holds concrete together. You see, making traditional cement is a total brute force operation. We have to mine limestone out of the earth and then cook it in these gigantic kilns at extreme temperatures. We're talking 1450 degrees Celsius. That, as you can imagine, takes an absolutely insane amount of energy. And here is the number you really need to remember: 8%. The cement industry, by itself, is responsible for about 8% of all global CO2 emissions. To put that in perspective, if the entire cement industry were a single country, it would be the third biggest polluter on the entire planet. That's just staggering.
And CO2 emissions? That's just the tip of the iceberg. The whole process tears up the earth, destroying ecosystems to get at that limestone. It pollutes the air we breathe, the water we drink, and the land we live on. From start to finish, it's just not a sustainable way to build our world.
And here's the real kicker. After all that environmental damage, what do we get for it? A material that's actually kind of brittle. Our modern concrete structures start to fall apart after just a few decades. Meanwhile, you've got Roman concrete structures that are still standing after 2,000 years. Something is fundamentally wrong with that picture.
Okay, so that's the problem. It's a big one. But what if we stopped trying to use brute force? What if we could learn from nature and grow our cement instead? This is where the story gets really, really cool. The solution is called biocement. It's made by harnessing a brilliant natural process with a bit of a mouthful of a name: microbial-induced calcite precipitation. Let's just call it MICP for short. Essentially, it's about using tiny living organisms to create a powerful natural cement. And you can literally see the difference under a microscope. On the left, that's your conventional cement. See how it looks kind of weak, almost cracked? But on the right, that's biocement. It's a dense web of interlocking crystals. It's just built fundamentally better, forming incredibly strong bonds. So how does this actually work? Well, think of it like you have an army of microscopic construction workers. You start by introducing a specific type of bacteria into a mix of sand. Then you give them their lunch, which is urea, and their building materials, a source of calcium, which can be something as simple as waste eggshell powder. The bacteria produce an enzyme that kicks off a reaction, creating these tough calcium carbonate crystals that lock all the sand particles together. Add a little guar gum to help it all cohere, and boom, you've grown a solid brick. Okay, I know, it sounds amazing in theory. But is it just a neat science experiment? Or does it actually hold up in the real world? Well, let's look at the data, because this is where things get truly exciting. The results are pretty clear. After 28 days, standard Portland cement could withstand about 32 megapascals of pressure. Not bad. But the biocement? It clocked in at over 35 megapascals. So let's be clear, this isn't just a weaker, eco-friendly alternative. It's actually stronger than the original.
But being stronger isn't even its most incredible feature. The most remarkable thing about this material is that, in a very real way, it's alive.
You see, those little bacteria, they don't just die off. They go dormant inside the material, just kind of sleeping. If a tiny crack forms and water gets in, it's like an alarm clock goes off. They wake up, get back to work, and produce more of that crystal glue, literally healing the structure from the inside. And they tested this. Look at these numbers. A 0.7 millimeter crack in regular cement barely healed at all over a month. But in the biocement, that same exact crack shrank to just 0.3 millimeters. It healed more than half of the damage by itself. Just think about what that means. Roads that fix their own potholes, bridges that last decades longer, a huge reduction in maintenance costs. It's revolutionary. So we've got a material that's stronger, heals itself, and is actually good for the environment.
The big question then becomes, can we really start building our future with this stuff?
Of course, for any new technology to really change the world, it can't just be clever, it has to be affordable. Can we actually make this stuff at scale without it costing a fortune?
Well, the initial cost estimates are incredibly promising. The research suggests that producing a batch of 100 biocement bricks costs around 1,280 Indian rupees. By using waste materials like eggshells, the cost stays low. This proves it's not just a lab curiosity. It has the potential to be a real, commercially viable product. So what's next on the horizon? Well, the roadmap is clear. It's time to scale up production, run real-world field trials on roads and in buildings, and maybe even develop ready-to-use biocement kits. There's potential to engineer even more efficient bacteria and get this technology written into green building standards. We are standing right on the edge of a future where our buildings are grown, not just built.
In the end, this research isn't just about a new type of concrete. It's about a whole new way of thinking. It brings to mind that famous quote from Mahatma Gandhi: "Earth provides enough to satisfy every man's needs, but not every man's greed." Biocement shows us that by working with nature, not against it, we can build a world that is stronger, more resilient, and truly sustainable. The question isn't, can we do it anymore? The question is, will we?